Hi everyone, my name is Olaf Ricard and I'm the project manager of the UCI Satellite 2 team.
I'm Joseph Leonor.
Roberto Hernandez.
So the background of the UCI CubeSat, it's a program that started in San Luis Obispo in 1999. And we started the program here about 5 years ago. The CubeSat is a miniature satellite used for space research, and it basically consists of off-the-shelf components made for student college groups. A 1 U CubeSat is defined as having a volume of 1 liter and a maximum mass of 1.3 kilograms. We're going to be building a 2 U CubeSat. So the goal of our project is to design a 2 U CubeSat to conduct an air pollution study, to test electrospray thrusters, and to test a thermal radiator. The thermal radiator is a study or a project that's in collaboration with the UCI spacecraft thermal team.
So our quarterly goals this quarter is going to be to complete the design and the analysis on the 2U CubeSat, to select a camera that can properly take a clear picture at polar lower Earth orbit, and to design and purchase deployable solar panels. And our last section is going to determine the optimal distribution of our electrospray thrusters and to conduct the vacuum testing of our electrospray thrusters.
So the budget so far, we know that the cost of launching is going to cost about $8,000. The total material cost we estimate is going to be about $3,000. So our total cost is going to be about $11,000. And I'm still waiting to hear back from our department chair about what our total budget is. So these are our teams. So I'm the project manager. Gilberto is the design lead. Joseph is the power lead, and under him works Josh. Our communications team, communications lead's name is Charlie Busraj, and our thermal lead is Jason. Our project advisor is Manuel Guerrero. We also have a separate component which deals with the experiments that go inside the satellite. So our graduate student, her name is Laia Ferrer, she handles the thrusters. I'm leading the camera experiments, and the UCI thermal spacecraft is leading the radiator. So as far as our organization goes, this is our quarterly Gantt chart. We are here in week 7. We are basically up to date with where we want to be in terms of the SolidWorks models of both of our design concepts. We're beginning the FEA on both of these. Joseph will talk a little later about the solar panel design. And then we are, so this last one is our documentation. Sorry, it's a little hard to see right now. But it's like a total document that we regularly update, which details the camera, the thrusters, like the progress, like so far. Another tool we began using this quarter is the Trello, where this is something we talk about every meeting, where it lists our to-do, doing, done, and things we weren't able to finish. So this is for our general project, and then each individual member has their own Trello.
So for the structural design, currently we are working on the 2U SolidWorks model and the FEA. So far we have 2 concepts. The first one you can see is just basically extended 2U cube, and it has rods connecting it, so it keeps the structure very well. The second one we're trying to do is more of a just drilled out concept of a cube. This way we have a lighter structure, and it allows us to manipulate any faces for the electrospray thrusters, cameras, or any other components we were thinking of adding to the satellite.
So for our solar panels, currently we're designing a printed circuit board to where the solar cells are going to be mounted on and connected to the actual satellite body. And then we're also looking into making deployable solar panels. And currently that's the SolidWorks of the hinge I found online for rolling tape spring hinges, which I'll talk more about the innovations about that later.
So also we're currently in development. Leah is designing a distribution mechanism, which basically takes the one take restriction that we have, which separates 7 different capillary tubes, so that the electric spray can be all around our satellite and we can have full control. Another thing she is doing, she is testing the electric spray thrusters in the vacuum chamber, which she currently can be doing. She needs 1 more week before she starts her testing. And the testing comprises of making sure that it's reliable. So at different level potentials that we give it, voltage potentials, we get the same current throughout, and we just want to make sure that it can last for our entire flight time.
So this is the work we've completed so far. Gilberto finished a 1U, an FEA, and a design on a 1U. The solar panel design, he selected the solar panels from the Spectral Labs. The electric spray thrusters, she's designed like test procedures for the vacuum testing, and for the camera, we've selected our lenses and our image sensors.
So future work, we want to fabricate the 2U after we've done all the analysis on it. For the solar panel, we want to build a solar panel since we're doing it in-house. It's really expensive to buy just solar panels and slap them onto our satellite. So if we build them in-house, it'll save us relatively a lot of money. We're also going to test the solar panels. Me and Joseph are going to be doing that. For the electric spray thrusters, she wants to conduct the vacuum test chamber. As we said, we have about a week before she starts doing that. She also wants to create a model for the distribution so we can implement it into our CAD model. And for the camera, we want to purchase it and test the camera lens.
So for our innovations, in terms of the solar panel, most hinges are heavy and complex. They require more mechanics, I'd say. And then, but the hinges that I've designed, or that I'm trying to design, are lightweight, simple, and self-restricting in the sense that the way you orient them, they'll move just that much, just in the way you want them to. If that makes sense. And then for electric spray thrusters, what's innovative about that is that it relies only on voltage difference, whereas earlier electric spray propulsion rely on pressure gradients. And the camera is innovative in that it can predict the depth of agriculture depending on the pollution around the area that we're trying to measure.
Thank you.
Questions? Sir?
So